continuing from last time, we're going to solve this triangle. We're going to use some laws of sines or law of cosines, depending on the situation. So I'm going to draw the triangle out. I'm going to cheat a little bit because I'm using a computer. So let's just use shapes, triangle, something like that. Why are you filled in with color? Like that. No fill. Thank you. All right. So in every triangle, the angles are the capitals. So A, B, C. And the lower cases are the sides across. So this would be lowercase a, this will be lowercase b, this will be lowercase c. In this scenario, I know this angle is 110 degrees. I know lowercase b is 35. And I know lowercase c is 38. Because I have a matching angle and side pair, I could use law of sines. And I think it's easier to use law of sines. I'm going to first find the angle for b. No, I'm going to do it because I want to make sure the recording hears it. So it's going to be sine of capital C over little c equals sine of capital B over little b. It does not matter if you put the sign on top or bottom as long as you're consistent. So if you put the sign on the bottom, on the left side, it should be sign on the bottom on the right side. So sine of 110 over little c, which is 38, equals sine of capital B, which I don't know what that is, over lowercase b, which is 35. So I'm going to cross multiply and get this by itself. I did that in the last video. So I'm just going to show the final result should be b, capital B, equals sine negative 1 of 35 times sine 110 all over 38. So I'm going to put that in my calculator. Yep. So I'm going to put that in my calculator. So just always make sure you're in degrees. If you're using degrees, radians, are using 38. They'll give you some decimal. Then you need to get rid of the sign, and that's sine negative 1. So sine negative 1 of 35 times sine 110, close that parenthesis, divided by 38, close the parenthesis of the original sine negative 1. I get 59.9. So B, capital B, equals 59.9. That would be just a rounding situation. So, yeah, it's just your roundings a little off. So if your roundings off at the beginning, it gets rounding off elsewhere. Since it's multiple choice, I'm not going to put an option where it's like 59.9 versus 59.3. It'll be like obviously, oh, that should be that one. Okay. Yeah, it happens. So 59.9. The purpose of it's not practicing rounding. That's the thing. So 59.9. Because that's 59.9, I'm allowed to figure out that this guy over here, you can subtract 180 from that. Is it 10.06? Yeah, 10.1. 10.01. 10.1. So 10.1. And now I need this A over here. I can't, just to be clear, because some people might think Pythagorean theorem, you can't do that because there's no right angle. So now you just have to do, again, the law of sines. This one is a little easier because you know the angle. I'm going to use the original one. I like using the original one just because it minimizes rounding errors like compounding. So I'm going to do sine of 110 over 38 equals sine of 10.1 over some mystery value a. I'm going to use a little algebra to get a by itself. You can't do that because there's no right angle. Yeah. So it's going to be a little algebra, 38 sine 10.1 all over sine 110. Type that in my calculator. I'm just going to type it in my calculator in my hand to be a little quicker because I want to make sure to cover everything. Divided by something. You'll end up getting 7.09. So I guess 7.1 ish. Yes. Capital A is 10.1 degrees, and then capital B is 59.9 degrees. Okay, let's do our next one. Again, we'll set up the triangle. I'm going to cheat because, I have a computer. Copy, paste. All right. Again, A, B, C, and across of it is the lowercase a, lowercase b, lowercase c. So in this case, I have lowercase b is 14. I have lowercase c, which is 23. I have capital A is 107 degrees. In this case, I do not have a matching angle side pair, so I'm forced to use law of cosines. Since A is the thing I'm looking for, or I'm sorry, let me rephrase that. I have the angle A, so A will be the isolated side. So it's going to be A squared equals B squared plus C squared minus 2 BC cosine capital A, which is going to be 107. But this is just the formula. Remember, whether it's A, B, or C, you just replace those positions. So we're going to continue. A squared equals 14 squared plus 23 squared minus 2 times 14 times 23 times cosine 107. And I hear you guys. I'm just going to make sure to say it out loud for the computer so it's recorded. So 14 squared plus 23 squared. Again, I'm just putting in my calculator in my hand just to go faster. Let's see, 107. I get that a squared equaling 913.3, but you have to square root it. Second square root of the answer, 30.2. All right, good. So I get this is 30.2. So here's 30.2. From there, I can use law of sines. Both the previous video, well, you know what? Let's just do it quickly. Negative 23? Careful. You should not get a negative side. I'm going to continue this. I'm just going to set up and then put it in my calculator. So sine capital B of 14 equals sine of 107 equals 30.2. A little cleanup. B equals sine negative 1 of 14 times sine 107 over 30.2. So capital B is going to be, luckily with triangles, after you get the first angle, the second angle comes for free. Uh, A over sine A. It doesn't matter which one is on top or bottom, uh, as long as you're consistent. So if you put sine on top on the first one, you gotta put sine on top on the second. So 14 sine 107 over 30.2. I end up getting 26.3. And then I can figure out this one plus 107 minus 180, 46.7. Now, if you remember, there was that special case where you have to do it twice. You will not have to do that in the final. I'm just going to straight up tell you. This one, it was technically that special case one. You do not need to worry about that though. If you remember, it could swing like inside or something like that, and you had to do it twice. Basically, you do not need to sweat that. That will not happen on this final. Okay. Okay. Yeah. What's up? Okay. So find the area of the triangle. In this section, we had a bunch of different weird area formulas. Does anyone remember any of them here? 1/2 BC sine A. Wonderful. Mm-hmm. Good. So I'm just going to plug it in. 1/2. If I'm calling this one A, this is B, this is C. Which one you call B and C actually does not matter, to be honest. But 1/2 times 7 times 4 times sine of 96. Again, just plug it in your calculator. Can't do anything else. You should get 13.9 if you plug it in correctly. 0.5? What do you put? 1/2. So 1 divided by 2, right? I got 13.9. Yeah. You probably just slapped a number wrong. That's why. Okay. All right. The word problems. I'm going to do all of them, but in the test, we have answer. I don't. I can't answer that right now. I'm not sure. They could be multiple choice. They could be open. Bill sees a flag on top of an upright flagpole. Looking at the angle of elevation, so he's looking up at 38 degrees of, not or, of 38 degrees. If Bill is 25 feet away, so he's 25 feet away from the base of the flagpole, how high is the flagpole? So we need to figure out this guy. Lucky for me, this flagpole is upright, so it's a right triangle. Because it's a right triangle, I can use the SOHCAHTOA. No need for law of sines or law of cosines. So in this case, from 38, this is the opposite. God bless you. And this is the adjacent. So since it's opposite adjacent, that's TOA, tan. So tan of 38 degrees equals opposite x over adjacent 25. So I'm going to times 25 on both sides. X over 25, right? He's 25 feet away. Oh, opposite over adjacent, TOA. TOA. Tan 38 equals x. Typed it in my calculator. 25 times tan 38. 19.5. So the flagpole is 19.5 feet tall. All right. In a skating routine, Jack and Kelly skates apart, starting at the same point at 15 degrees. So Jack went one way, and Katie went the other, or Kelly went the other way, and there's 15 degrees in between. If Jack skated 8 meters, so we know he went 8 meters, and Kelly skated 5 meters, so Kelly skated 5 meters, how far away are each other? So I want to know how far away is from Jack to Kelly. So I want to know this red dotted line right here. I don't know how to answer that. That's the tough part. You have to just realize if they're coming from the same point, then I know, like if they were leaving something behind, there would be a trail behind them. If they're skating, there'll be. We know they didn't go straight because I told you they went 15. In this case, no, because there's no pair, so you're forced to use law of foresight. Yeah. So remember, it's always the one like you have the angle matching with. In this case, it's this x. So x squared equals 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of 15 degrees. I'm going to type that on my calculator. 5 squared plus 8 squared minus 2 times 5 times 8 times cosine 15. So x squared equals 11.7. I got to square root both sides. So x equals 3 point something. Second square root, second answer, 3.4-ish. So your answer is 3.4. I got 2. Did you get 11.7? That's way off. Careful what you typed in. Did you forget the 2? I don't know. Let's talk about number 3. Two observers, Adam and Becky, are standing 2 miles apart from each other. So the only thing I know is Adam and Becky are 2 miles apart from each other. So I know there's 2 miles distance between each other. They're both looking at a boat at the ocean. Adam is looking at, there's some boat out here. So, little boat. So they're both looking at the ocean, okay? Adam is looking at 54 degrees, and Becky is looking at 68 degrees. How far away is Adam from the boat? So X will be this left side between Adam and the boat. In this case, I could probably figure out what's the angle in between the boat. Good. So we're going to subtract that from 180, and I'm going to get 58. So this is 58 degrees over here. Because I have an angle and side pair, I'm allowed to use law of sines. Yeah. Or some variation of this, yeah. So sine of 58 over 2 equals sine of 68 over my mystery x. Gonna clean it up with a little algebra. Bring me your calculator so I can see it. Sine 68 all over sine 58. All right, your job is with my calculator. Calculate this so you can give me the answer. All right, I know the problem. You ready? The cosine's here. What you're doing is this first and then multiplying by cosine. That's the wrong order operations. So you should do this times cosine 15 and this one. And then you'll get 11.7, square root that, I'll give you that. Divided by sine 58. Yes, so 2.18. So 2.2. So Adam's 2.2 miles away. Yeah. Uh, if you call this C, this would be little c. Yeah. All right, last one, number 4. On a map, Easton is, yeah, 2.2 should be your final answer now. It's 2.16 or 1.8 when it pops up in the calculator. On a map, Easton is 18 miles from Centralville. So here's Centerville, and 18 miles east. Hopefully, you know your compass is east, and that's 18. Knottonly is 15 miles northwest. So northwest would be this way, and that's 15, and that's Knottonly. So K. How far is Easton from Knottonly? So I want this dotted line. It's this mystery X. The question is, how do I know this angle? This angle should be 135. Yes, it's from east to northwest, which is 135 degrees. 90 degrees to go north, and then 45 degrees to go northwest. So we could conclude this is 135, which again means we could do a law sine situation because I don't have a matching, or law cosines, my bad. So x squared equals 15 squared plus 18 squared minus 2 times 15 times 18 times cosine of 135. Remember, in general, to check your work, you know the x should be the biggest side because it's across the biggest angle. So if you don't get a number bigger than the other two numbers, you know something went wrong from this section, if it's on the test. What? Um, because I'm going northwest from east. Let me see where you're looking. So this, right? To get to north, that'd be 90 degrees. And then northwest is in between north and west. So that's 45. So what's 90 plus 45? That's how I get 35. Yes, that sounds good. Because when you get x squared equals 930.8 ish, and the second square root, the second answer, 30.5. All right, cool. We could go to the next test. 13.1 to 13 point. Yes. That's the final answer? Yes. I did not open that one. Let me open it for now. Test 11. Your packet's been the whole test. Do you not have the packet with you? Yeah, it's just all the tests stapled together and me going through it in a video. I feel like it's yes, yes, it is. What? Except for one of them because some people need to make it up. Otherwise, it's all of them. Oh, and except the one that Miss Kirsten gave you. I'll do a video of a fake version of that test, so don't worry about it. All right, express for 20 degrees in radians. So whenever I'm going from degrees to radians, pi is on top. So it's going to be whatever you get times pi over 180. Because I'm going to radians, that's on top. So 420 times pi over 180. Just simplify, take out a zero, take out a zero. 7 over 3. So 7 pi over 3. You could take out a, not 9, you could take out a 6. You could take out 60, I guess you should say. Yeah. Oh, let's say if you didn't know how to do it in your calculator, if you just put 420 for 420 divided by 1 to do what? This, no. What we just did, no, you do not change the radians. But if you go to math frac and just press enter, that'd be 7 over 3, so that's 7 pi over 3. Same thing here, 7 pi over 4. So since I'm going to degrees, I got to put 180 on top in this case. So the pi's cross out. I could reduce this from 4. This is going to be 1, and this is going to be 45. So 7 times 45, 315 degrees. 4 and 180 becomes 1 and 45. Again, you can, yeah. So it's just 7 times 45. All right. A circular sector has a radius of 5 and a central angle of pi over 3. What's the measure of the arc length? What's the measure of the area of the sector? The formula for this, it was part over whole equals part over whole. So part is going to be your angle over 360 equals your arc length, which is arc AB or whatever it might be, over your 2 pi r, because we're using arc length. So we know the central angle is pi over 3. You could change it to what's up? No. Well, you did something related to this, yes, because you did things with spheres and stuff. You should have done things with circles, I should say. But they're related because you're doing an angle anyway. So pi over 3, you would like to change that to degrees. So that ends up being 60. So 60 over 360 equals the measure of the length, which is what I'm looking for. So I'm going to call that x, over 2 times pi times 5, because that's my radius, which is 10 pi. Cross multiply and clean up. I mean, I could simplify this to 1 over 6. So it's going to be 10 pi over 6 equals x, which you simplify to 5 pi over 3 over x. I times 10 pi on both sides. So this will be 5 times pi. What's up? 60 divided by 360 is 1 over 6. There's six. Is it 1 out of 5? No, there's 660s in 360. 2 times 5. You could, and you'll get it. Yeah, it'll work out. Either way, whatever you do, your answer is going to be in the calculator 5.24. It rounds up to 4, technically. 1 over 6, not 6 over 1. Because 60 is on top, not 360 on top. Yeah, yeah. Next one, similar setup, 60 over 360 equals my mystery over, in this case, it's pi r squared. So this one is going to be 5 squared. So 1 over 6 equals x over 25 pi. Julia, the easiest way to do it, let's say if you had it like this. Hold up. If you have this, Julia, this times 10 pi on both sides. So you you just do this right here. Just type that in a calculator. Why do you think you have a calculator? Yeah, that would work. Same thing over here. I'm gonna get. Yep. What's up? I don't think anything's simplified, so I just gotta take my calculator and divide them, which is gonna be about 13.09. I just got 2 decimal points because usually with pi you go 2 decimal points. There's no real hard rule about that, but it's just what it is. All right, number 4. Give the exact answers for the 6 trig functions at 5 pi over 6. So somebody already converted it. It's 150 degrees. Again. So you should be doing the 6 trig functions at 150 degrees. There's a lot of. It's okay. Sine is going to be 1/2. No, it's 30. Related to 30. So cosine is going to be root 3 over 2. It will be related to 30 degrees. What? Oh, the x and y would be negative root 3 over 2, comma 1/2. And then we just, that's what it would be on the unit circle. Again, there's a lot of videos on Unicircle, and there's so many ways to remember Unicircle. I'm not going to spend time on this videos doing the Unicircle. It's something easy to at least figure out, or something that's not easy to figure out. How do I say? There's a lot of ways to do it. It's very common threaded, the subject. So negative root 3 over 3. I just want to make sure clear that's a negative. Cosecant. You just flip the things, so that's 2. Uh, C secant equals negative 2 root 3 over 3. And then cotan is going to be negative root 3 after you clean it up. Okay. All right. Yes. Yes. Cos is x sine is y. All right. If cosine x equals 12 and 13, 12 over 13, and sine of x is less than 0, find the other 6 trig functions. So first off, I know cosine is 12 over 13, which is positive. So it has to be the first or the fourth quadrant. Then sine x is negative. So sine x is negative happens in the third or fourth quadrant because it's positive in the first or second quadrant. So we know it should happen in the fourth quadrant. Uh, this part is positive. So I know that's from either the first quadrant or the fourth quadrant. And this part is a negative. So I know that's the third quadrant or the fourth quadrant. It says sine x is less than zero. And anything less than zero is negative. Since this has to happen in one or four, and this has to happen at three or four, the only way it happens at both times is four. That's where they're positive, right? All students take calculus. So if sine is positive on one and two, then sine is negative at three and four. Yeah, the overlap. Pythagorean theorem. You will do some Pythagorean theorem, but you still need it for the negatives. You could do that. So, like, I'm about to do that now. Cosine is x over r. So that's going to be 12 over 13. And someone remember their Pythagorean triples. This should be negative 5, though, because I'm going down. I'm in the fourth quadrant. So now I can do all my sines. 13 is not negative because it's in the fourth quadrant. Yeah, because going down is negative. What quadrant? We talked about that. No. Oh, cosine, you could either think of x over r or you could think of adjacent over hypotenuse. Either one works. Here's the right angle. All right, so sine. So sine is going to be y over r, so negative 5 over 13. Cosine, embarrassing if you mess that up because they give it to you, 12 over 13. Um, tangent, opposite over adjacent, or y over x, so negative 5 over 12. And then we're just going to flip everything for the rest. Cosecant is negative 13 over 5. Perfect. 13 over 12. And then tan, or cotan, oops, is negative 12 over 13. Negative 12 over 5. No, y is always opposite if you want to think of it like that. You got to think as the angles coming from the origin. So, well, I don't know how to explain how to draw a triangle. At that point, I'm stuck. So, all right. They got a song for everything these days. All right. Even, odd, or neither. So, evens, what would happen is, well, hold on. Think of it like this. This is how I remember it. If it's x squared, when I plug in a negative number, it's the same as if I plugged in a positive number. AKA, negative 2 squared is 4, and positive 2 squared is 4. No, f of negative x equals f of x. Odd, how that works, I think of x to the third power, where when I plug in the negative, I get the negative answer as if I plugged in the positive, which sounds wordy, but basically it's like this. If I plug in negative 2 to the third power, I would get negative 8. Plug it in positive 2 to the third power would give me positive 8. So these answers are opposite by sign, while these answers are the same by sign. So even, you have the same answer when you plug in negative and positive. And odd, you get opposite. Odd for opposite answers. And in general, sine is starts at one, right? Sine is even, cosine is odd. All right. The sine wave looks like what? Like this, right? Starts at one. Even is that it's symmetrical on the y-axis, so that's symmetrical. So that's even. Oh, sine starts at zero. So yeah, you're right. Okay, you're right, you're right. So sine is odd. Cosine's even. Yes, you're right then. My fault. So in this case, I'm going to plug. You could either plug in a number or plug in negative x. I could plug in a number. 1 cubed minus 4 is -3. -1. Oops. -1 to the third minus 4. That's -5. Are these opposite answers? Are these the same answers? No, so it's neither. If they were odd, you would get like 3 and -3. If it was even, it would be -3 and -3. The same answer when you plug into positive or negative. Even would be the same answer. Odd would be different answers. Opposite. I'm sorry, opposite. Yeah, negatives to each other. All right, sine. I'm gonna plug in. Since I'm dealing with sine, I gotta think of something like that makes sense. So let's do. No, it has to be something you can plug in. Sine. Let's say hold. Let's say √2/2. If I plug in √2/2 times sine √2/2, what's sine √2/2? Anyone knows? Oh, I'm so dumb, actually. Yeah, I'm stupid. It's not sine √2/2. That's the answer. It's gonna pop out. We gotta put in when you plug in real numbers, you gotta plug in radians. So we're gonna put pi/4, and then when you're dealing with real numbers, so this is a real number, it's radians. But pi/4, when I plug in pi/4, this is pi/4 times √2/2. So that's going to be, this is √2 pi over, because sine at 45 degrees is √2/2. Yeah, it's safe with them. I don't care what you do with them. Then I'm going to plug in the negative. Negative pi/4 turns sine. What? Fifth period? Hold up. Let me just finish this for my video. So then it's going to be negative pi/4 times negative √2/2. So that is going to be positive √2 pi over 8. Since these answers match, it's even.